Welcome back to The Explainer. Today, we're exploring a truly fascinating intersection of two completely different worlds, criminal law and complex statistical physics. We're going to objectively unpack this amazing case study from our source material, where the defense actually uses advanced scientific models to challenge a legal accusation. It's like this giant puzzle, showing exactly how we can use structured science to analyze human systems, and I'm so excited to guide you through this one.
So, can one single retweet literally cause widespread chaos? I know, it sounds kind of like a philosophical riddle, but this is the exact theoretical conflict at the heart of our explainer today. We're going to look at how a legal accusation of disrupting public order holds up when we subject it to the rigorous mathematical scrutiny of network theory and thermodynamics.
Here's our docket for today. We'll start by looking at the single retweet accusation, then we'll explore the anatomy of scale-free networks, branching processes and subcriticality, fluctuations versus phase transitions, sandpiles and avalanche dynamics, and finally, breaking the causal chain. Let's dive right in.
Section 1. The single retweet accusation, where we examine the legal premise.
Okay, so here are the objective facts of the accusation based on the source documents. We've got a defendant whose social media account has under 100 followers and historically essentially zero engagement. Yet this individual is being charged with causing severe macro chaos through just a single retweet of a post. The glaring disparity here is wild. It's between a micro action, just a single click from an unknown account, and the macro accusation of severe societal disruption. Now, in criminal law, the prosecution has the burden of proving direct causality. They absolutely must prove that this specific retweet caused this specific chaos. But how does that even work mathematically? Let's move to Section 2, Anatomy of Scale-Free Networks. It's time to call our first scientific expert to the stand. You know, to really grasp how information travels, we have to understand the underlying architecture of the internet. Our sources explain that social media operates as a scale-free network. Basically, this is a network that follows a power law distribution, meaning it is not some egalitarian web where everyone has an equal voice. Not at all. It's highly structurally unequal. It features a tiny handful of extremely connected hubs, while the massive, overwhelming majority of users are what network scientists call peripheral nodes. Think of it this way. You've got a peripheral node, like our defendant, under 100 followers, isolated with virtually zero structural impact. They're basically just shouting into the void. Then you've got a hub node, millions of followers, highly connected, entirely capable of system-wide reach. In network theory, removing or activating a peripheral node practically leaves a scale-free network completely unchanged. It is structurally incapable of causing a system-wide effect on its own because, well, it simply lacks the connections to do so. Section 3, Branching Processes and Subcriticality. Let's look at how we model the spread of information. To trace the physical spread of a retweet, the defense uses this really cool mathematical model called the Galton-Watson branching process. The whole core of this model hinges on the concept of a subcritical state. This is a state where the average number of new branches, which is represented by the letter M, created by a single event is less than 1. When M is less than 1, the math is absolute. The cascade inevitably dies out. Without enough momentum, the extinction of the information is a mathematical certainty. It's actually pretty straightforward when you break it down. If M is greater than 1, the system is supercritical, which leads to an exponential explosion. That's your viral trend. If M equals exactly 1, the system is critical. But if M is less than 1, we are in the subcritical zone, and the expected outcome is, again, inevitable extinction. So, given the defendant's account had fewer than 100 followers and essentially zero engagement, what do you think their M value was? Well, according to the defense's calculations, based on very conservative estimates for a peripheral node with a standard sparse forwarding probability, the expected total cascade scale is merely 1.02. That literally means one retweet leads to, on average, 0.02 additional retweets. It doesn't even successfully reach a second person's screen. This proves the account exists in a deeply subcritical state. Statistically speaking, it's impossible for this node to trigger a macroscopic avalanche of information. Moving right along to Section 4, Fluctuations versus Phase Transitions, or how we distinguish a ripple from an absolute tsunami. Now, remember, the prosecution claims the defendant caused severe chaos. In the language of statistical physics, a severe, systemic disruption is called a phase transition. This is a massive macroscopic change in the overall organizational structure of a system. Think of water freezing into solid ice, or a magnet becoming magnetized, or, in a sociological sense, a stable society suddenly falling into utter chaos. It's a fundamental shift. The defense argues that the legal accusation fundamentally conflates two completely different physical phenomena. On one hand, we have a local fluctuation. This is a micro-disturbance, a gentle breeze on a lake, a single person shouting in an empty square, or a single retweet by an account with 100 followers. By its very nature, it will quickly dissipate. On the other hand, we have a macro-phase transition, a true structural system change. The defense asserts that treating a tiny local fluctuation as the direct cause of a macro-phase transition is just a severe logical fallacy. Which brings us to an absolutely crucial concept, the fluctuation-dissipation theorem. This theorem states that a system's response is equal to the fluctuation multiplied by the system's sensitivity. Listen, if a tiny fluctuation, like our 1.02 retweet cascade, somehow results in a massive systemic response, the math dictates that the fluctuation didn't do the heavy lifting. The only way that equation balances is if the system's sensitivity is incredibly high. If a tiny retweet causes massive chaos, physics says it's a system's own extreme pre-existing instability that is at fault, not the retweet itself. This leads us perfectly into Section 5, Sand Piles and Avalanche Dynamics. Let's look at the actual science of system collapse. So why would a system be that sensitive? To explain this, our source material turns to physicist Per-Bach's theory of self-organized criticality, or SOC. This theory suggests that complex systems under a continuous external drive will naturally evolve toward a critical state where a single, tiny disturbance can trigger a massive avalanche. The absolute best way to visualize this is through the famous sand pile model. Imagine you're dropping grains of sand, one by one. The pile naturally builds up, getting steeper and steeper to a critical angle. Eventually, you drop the 1 millionth grain of sand, and boom, it causes a massive avalanche. Now ask yourself, did that single grain of sand possess the kinetic energy to move half the pile? No way. The true cause of the avalanche is the accumulated, unstable structure of the pile itself. In statistical physics, that single grain is merely the trigger, not the root cause. If the system wasn't already in a critical state, that grain would have just rested harmlessly right on top. Finally, Section 6, breaking the causal chain. Let's synthesize all this for the final verdict on the legal accusation. To establish criminal liability, a court generally requires some pretty strict steps. First, an objective behavior occurred. Second, a harmful result manifested. Third, a causal link is established. They often use the but-for test for this, like, but for this action, would the result have happened? And fourth, objective attribution to the defendant. Well, the defense uses all the science we just went over to completely sever Step 3 and Step 4. Here is exactly where the scientific models demonstrate a hard break in the legal causal chain. First, the defense notes a total lack of empirical evidence of actual chaos. There were no mass riots, no service outages. Second, as we learned, a deeply subcritical node with an M value of basically 0 mathematically cannot sustain a cascade. Period. Third, blaming the node conflates a local fluctuation with a macro-phase transition. Doing so commits what scientists call the micro-macro fallacy, because it completely ignores the fluctuation-dissipation theorem, which firmly points the blame at the system's pre-existing instability. Which leads us to the core philosophical and scientific takeaway from all of this. Macro-order changes are driven by system structures and critical states, not peripheral individual behaviors. A peripheral node in a scale-free network simply does not possess the structural capacity to single-handedly engineer a phase transition in a complex system. It's just not possible. So it really makes you wonder, when we look at chaos in our highly connected, super complex modern world, are we just blaming a single grain of sand for the instability of the entire sand pile? It's a pretty profound way to rethink causality in the information age. Thank you so much for joining me today, and I'll see you in the next explainer.